Good afternoon, guys. This is day 17. And today we're going to be working on simplifying rational expressions. We begin with a meme from Mr. Hawkes, and we have a rational expression that's been incorrectly simplified, where they crossed out the x squared from the top and the bottom. You'll see after today's lesson that that is not the approach, hence the joke. So let's go ahead and get into our notes for today. I'll go ahead and move it on down. Let's see the next page. All right, so our first example, x plus 3 over x squared plus 5x plus 6. Our previous lessons were about factoring quadratic equations, and that was because you're going to need that for this lesson. So what we're going to do first is we're going to rewrite this expression. If I can get my pen going. There we go. I'll keep the numerator on top as is because there's nothing there to factor. On the bottom, however, I will factor the quadratic equation. So to get the x squared, I need x times x. To get the rest of my factors, I need two numbers that multiply to a positive 6 and add up to a positive 5x, or a positive 5. And those two numbers would be positive 3 and positive 2. Now I'll go ahead and simplify. Anything that's common to the top numerator and the bottom denominator can then be canceled out. For example, I have x plus 3 on top and x plus 3 on the bottom. X plus 3 divided by x plus 3 gives me a positive 1. And I'm left with x plus 2 on the bottom. At this point, I can just drop off the parentheses. I don't necessarily have to have them, or you can leave them on. It doesn't really matter. But there's the simplified form of my equation. It's pretty basic. So let's go ahead and try our second example. By the way, that is the conclusion of our first example. There's no more to do there. 1 over x plus 2. The remaining factor is your answer. Now we have the quadratic formula, or excuse me, the quadratic equation on top. The numerator. So what I'm going to do is go ahead and factor it. X times x gives me the x squared. Now I need two numbers that multiply to negative 14, which means I'm going to have one negative and one positive. And then I need two numbers that also add, those same two numbers need to add up to a negative 5. So what I'm going to have is a negative 7 and positive 2. Negative 7 times positive 2 gives me negative 14. And negative 7 plus positive 2 gives me negative 5. So there's my factors in the numerator. On the bottom, I'm going to factor this by taking out a 3. Everything can be divided by 3 in this bottom part. So I'll factor out a 3, and then I have x minus 7, because 3x divided by 3 is 1x, and negative 21 divided by 3 is negative 7. Now I'll take out any common factors, and I have the 1x minus 7 in the numerator and denominator. So in my numerator, I'm left with just x plus 2. And in the denominator, I just have that positive 3 that I factored out. And that's my answer. It's pretty easy, pretty basic. Moving on to number 3 now. So I can scroll this up. Now that the screen works better again. Number 3. So we have two quadratics now. So I'm going to have two equations that need a factor. In the numerator, I have my x squared, which is x times x. Two numbers that add up to, two numbers that multiply to negative 6 and add to a positive 5. That makes me add to a positive 1. I don't know why I said 5. Would be positive 3 and negative 2. Now I need to factor the bottom, the denominator. X times x is x squared. Two numbers that multiply to 15 and add up to 8. Both would have to be positive since I have double positives. That would be 5 and 3. Now to simplify by removing anything that repeats in the numerator and denominator, and that'd be the x plus 3 factor that I have here. So in the numerator, I'm left with x minus 2, and in the denominator, I'm left with x plus 5. You know you can't factor out the x's, so they stay just as is in this form. And moving on to the next example now. More of the same thing. Number 4. Now, what I have is a perfect square binomial. To get the x squared, I have x times x, just like before. But now I need two numbers that multiply to negative 25. When they add up, they give me 0, because there's 0x here. This equation on top can be rewritten as x squared plus 0x's minus 25. This equation already expects that you know that in your head. So if you don't, feel free to rewrite it. Since I have no x's, what two numbers multiply to negative 25 and add up to a 0? They have to be opposites in sign, and that would be negative 5 and positive 5. Now to factor the denominator. X times x gives me the x squared. I need two numbers that multiply to 30 and then add up to negative 11. And that would be negative 6 and negative 5. Negative 6 times negative 5 is positive 30, and negative 6 plus 5 more negatives is negative 11. Now to remove any common terms, I have x minus 5 on top and x minus 5 on the bottom. So what I have remaining then is just a singular x plus 5 in the numerator and x minus 6 on the bottom, and that is my final answer. I cannot simplify it any further. Now, number 5, our last one, requires a bit more work, but nothing too complicated. So what I'm going to do first is I need to use my rule for factoring equations or quadratics with a coefficient higher than 1. So I have to deal with that 4. I'm going to take the 4x squared and multiply this first 4 times the negative 3. So now I have x squared minus 4x minus 12. This I will now factor. X times x is x squared. Two numbers that multiply to negative 12 but add up to negative 4 would be negative 6 and positive 2. Remember now, since I multiplied everything by 4, I now have to divide these answers by 4. Well, these fractions don't give me any whole numbers, but they can't be simplified. I get 6 minus 3 halves when I simplify, and then x plus 1 half over here. I'm still not done with just the factoring part. Now I have to rewrite these. Remember, you take the denominator and you slide it in front of the x when you have a fraction answer. So my first factor becomes 2x minus 3, and my second factor becomes 2x plus 1. This goes back to day 16, I believe, homework. So there's my numerator, 2x minus 3 on top, and 2x plus 1 on the bottom. Now let me work on factoring the bottom one. To show the work, and then won't get too confusing, I'll go ahead and just rewrite it over here on the side. 2x squared plus 7x plus 3. I take my leading coefficient and multiply the constant at the end times that. I get x squared plus 7x. 3 times 2 is a positive 6. Now I factor these. X times x is x squared. What numbers will multiply to give me a positive 6 and add to a positive 7? That would be positive 6 times positive 1. Now I go back and divide both these answers by the leading coefficient of 2. This factor gives me x plus 3, so that's good. The second one gives me a fraction answer, which I have to convert to 2x plus 1. So my bottom denominator factors are x plus 3 and 2x plus 1. Whatever's common to the top and the bottom can be simplified and removed. So I'm left with a final answer of 2x minus 3 on top and x plus 3 on the bottom. And there's no further factoring to be done. So here are 5 basic examples on how to simplify rational expressions. It relies on you being able to factor and knowing the rules for factoring in order to be successful at this. So hopefully this was an easy lesson for you, and you may now go ahead and start on your day 18 homework if you understand this. All right? Best of luck, guys.